UT guys. So, all right, great. We are live. Hey, everybody. Sorry, I started a couple minutes late. I know a couple people who are going to be watching and chiming in on the comments, but great to be back for our weekly Epiphyte stream where we try to move through and make progress for our next and future builds. We have a lot to discuss today. And yeah, we can get kind of right into it. We might have a few other people join us on the front end here. We'll wrap up at 45-minute mark instead of the hour. And there was one other thing I wanted to share. Oh yeah, the other thing too is we have a few members of the team who are students who can't make this time. So our group here was able to find another time. It's the same hour, but a day earlier. So we're going to shift to Wednesdays next week, and that's going to allow some people on the UT team to join. So anyway, how you guys doing? Seth, you must have like the quads of steel here, man. I don't know if I've ever seen you out walking. I admire I can barely get my lazy butt to use this as a standing desk, let alone one that I walk at. So kudos to you for that.
I hate sitting. I need to keep moving.
Yeah, that's great.
It's not about fitness. It's just about keeping moving.
Yeah, I'm kind of that guy as well, but I usually just bang my Twitch a lot rather than more productive move around. But anyway, well, hope you guys are all good. So let's just start kind of openly here a little bit. Last week we talked about let's get all the different parts that we're thinking about at this point on a common document that we can then look at and compare and stuff like that. So I went ahead and did a starter version of that, which I shared with you guys on the Discord. And so what I attempted to do here was to list the major components that we're looking at, some of the necessary specifications, and then gave some sort of options that fall under those components, put little pictures in there, links, and some sort of notes that we know about that product and where it might be good and where it might not be good. So I didn't get everything I wanted up there, but I did get a lot. So was that kind of David, Seth, and Ling sort of at least the type of thing that we think will be helpful for us?
Yeah, so we can keep adding to it.
Okay.
Yes.
Great.
I would offer a suggestion of another tab maybe to add.
Yeah.
Maybe do it on a more of a document sheet. And that would be just a sketch of the overall architecture we're thinking about.
Yeah.
And that people could modify it or make comments on it. So we're all looking at the same picture.
Yeah.
You had a lot of videos of your ideas. I think it would be good to have them in the list so that if people want to refer to them and see or like draw ideas from them, they're good to have.
Yeah, I think that would be great.
Yeah, it's hard sometimes to go back 20 screens or so to find something you're looking for that you think you remembered seeing.
Yeah, totally. I can take the little Canva slides that I make basically and just make those static PNGs or JPEGs or a PDF or whatever, and either make it a separate document or it's even possible to insert large images into cells even if we wanted to keep it on the same, but I can make a separate document as well. So that sounds
You
good.
can just link them. I think you can make Canva things.
Oh, yeah.
Only or put it in Google Drive.
That's a good idea actually, is to put it all in Drive, but just create a tab here where maybe it kind of labels what the model shows and then just has a link to a file that's shared on the Drive. I think is probably a good way to keep it all tidy. All right. Any brilliant instances of creative thinking or problems or anything like that we want to just discuss openly, and then I can share some of the responses I got from some of the parts suppliers related to that list that I just showed. But let me know if anybody has anything to discuss first.
Do we lose Seth?
Yeah, he'll probably right back on.
Sorry, my brain wasn't working this week.
No worries. You guys want to? One thing I took a dive into was the trying to find out, he said, let's do a plastic tube. And I found that through all the kind of research I've done for different high temp, options, there's some issues with each one of them. And I didn't know if you want me to share what I found out or if you want to start somewhere else.
Sure, I'm interested in hearing about it.
All right, cool. So let me go back to this real quick and see if I can zoom in even just to kind of show you what the thing I was particularly interested at. I don't know if you guys can see those. I can show it on a slide, but there's a number of different cylinder materials or materials that are used for cylinders that might fit our needs in terms of dimensions and stuff like that. And so I did a lot of research online to find out what's off the shelf and then what costs are. So I reached out to a lot of suppliers who you have to get quotes from. And so I'll just go through what I found out. One that we found really promising, if you remember, was this polyphenylene sulfide or PPS, as well as PSU and polycarbonate. And what I'm finding with this is the pricing on these is just absolutely insane. It's not like PVC where you can get whatever the hell you want. And PVC has like a 60 to 70 C max temp. So for these more specialty polymers, like they're all really quite expensive. And it was acrylic also would be awesome. It'd be so cool to have like a see-through pipe like that, but it doesn't have the heat requirements that we need. And then I looked into a couple of other ones. So alumina, like a ceramic pipe, seemed like a really interesting idea. Those are also wildly expensive, at least the ones that I've looked at. For even, sometimes you can't even buy as small as we want. Carbon fiber, the only one I could find off the shelf, this is also way too small. This is like an interior diameter of like 2 inches or something. And, that was really, really expensive. But some other options I found that I thought could be worth exploring. And I talked to these guys today, this vitrified clay option, like those are extremely hard. And they can be made to order in the kinds of dimensions we want for pretty cheap. So the one company I called in Ohio could ship us an 8-inch interior diameter, 5-foot length clay pipe for like $300. And then they have these other things. Like the concern there seems to be, how do we join it up with metal parts? We don't want to drill a hole in a clay pipe. But they have these various things that are kind of meant for that, these like gaskets and connector parts. So I thought that was kind of an interesting option. So let me pause there. There's one other thing that I did discover that I think might be the direction we want to take. But first, just let me know if you guys have any questions about what I learned about those 3 things.
I wonder if something like that kind of pipe could be picked up, say, at a plumbing supply store. Maybe not that size, but smaller pieces.
For which, I think it can. It's just about the material. Like if you go to a plumbing or a Granger or something, they'll have PVC and then they'll have metal parts. But some of the things about trying to make sure we can get hot enough and it's not going to melt it, those seem to be more specialty. But I don't know. We can go take a look. I drove by a Granger yesterday. I almost went in, but I had to take my kid home.
I like that clay idea. Like, if you're gonna spend $1,000 on plastic, you might as well just use Pyrex.
Yeah, exactly.
So
Yeah.
what about the metal HVAC tubes what's wrong with those?
So this is the thing too, which one of the things that's been fun with this is how we kind of like go and ransack other fields to find parts. And obviously we were really dialed into HVAC from the very beginning of this, and that made a lot of sense. But if you think of other things, like what else is tubular? Air needs to flow through it, but it needs to be able to get really hot. So a lot of those HVAC parts that I found they don't meet our needs in terms of, certainly the basic chamber we could use for that, but some of the other stuff is not necessarily ideal for that. And if you remember last week, I was like, yeah, I like the vertical because it kind of is the metaphor of a chimney. And then I got to thinking, I was like, well, what about literally chimneys and stoves? Like what do those things do?
Yeah.
And that was where I found this stuff, which is the thing that's awesome about this. It puts us back into stainless steel territory, which we'll talk about in terms of heat absorption. One of the reasons why we didn't, like it. But it has a lot of other things that really recommend it. It's got all kinds of these pipes that then fit into these other locking parts that are actually quite useful for us, right? So the chimney one, if you did a double wall chimney, like a 7-inch or 8-inch diameter, it's got 8-inch, 7-inch, all the way up to 14, 24-inch length, 36, 48. You can do any number you want. But these double wall ones make it less hot to the touch. And it also possibly opens up the opportunity of inserting something like a ceramic blanket or a silicone layer that would then create more better thermal properties, not just so it wouldn't be hot to the touch, but you could potentially line the inside of it that would create a barrier maybe between the metal and the monolith itself. And then it has like these T pipes if we did want to go through a thing that had a separate pipe so that the air could flow through that and didn't have to go through a heating element. It's got this little top hat jobby slip connector that could be like a stand that you could also put the heater in. And then it has these, I talked to them today on the phone. These dampers can go up to like extremely high heats as you would expect for a chimney. And I was like, well, it doesn't have an actuator, but I looked up like a whole bunch of companies that have these standalone actuators, like Belimo or whatever it's called, that you could potentially add an actuator on the outside of it. So anyway, that I thought was kind of interesting. And they're relatively affordable, but high temperatures, they could potentially be insulated, all kinds of components that are in that 6 to 8-inch diameter that click, high heat, and all those parts together would be like $400. So
yeah. So to clarify, I was never against stainless steel made anything. The problem was trying to insulate the existing thing that we have. That's like a weird shape, and it's a lot of surface area to insulate. So like insulating that is complex and expensive. So I'm not against like a normal like another piece of stainless steel, and it does have great thermal properties. But our piece of HVAC piping is not practical for both that reason, and also it can't hold a vacuum.
yeah.
So like stainless steel is fine.
Yeah.
Double wall sounds great.
Cool. And it looks like we don't need much vacuum. Like the vacuum's not doing the work of stripping the CO2 from the sorbent. It's really the heat that does that. It's more just evacuating the chamber. So it seems like relatively low pressure would be fine without turning this into like a Titanic, submersible here. But anyway, I love the look of this stuff here because it's just so made to, it has a lot of the parts here that we could just kind of hack. So I don't know. That's my latest thinking on it, and it's cheap.
That looks good. Looks very good.
I like
Promising.
the black powder coating too. Yeah, it could look pretty cool of all the parts. I don't know. What do you think, David?
It looks like definitely worth considering.
Yeah. And then I made this very silly mock-up though, but assuming those kinds of parts, one thing we could do, Ling, if we were thinking of a separate fan that you create another hole so it doesn't get in the way of other stuff, you could use that T joint there that you can see there on the bottom and in the middle. You could potentially add the damper there and the fan, so it's like a right angle. And then if you had that slip thing, if we went with that heater that I showed last time, this guy, which gets really, really hot and it's small, you could kind of slip that in the bottom and have the bottom be sealed, where there's no damper because the damper's on the side. And then you just fit the chimney pipe on there and then, you're good to go. I don't know, I could see something like that working.
I gotta look at that piece of heater again. Sorry, I didn't really look very closely. I just don't know if it blows. Like, does it blow air?
No, this doesn't blow. Again, if this was below it, we would hope that the rising heat would sort of naturally sort of move. But I don't know.
That could be kind of slow if you're just relying on the buoyancy from the heated air.
Yeah. What if on the bottom, I was also asking the same guy that they have these metal fans that are circular that have pretty high static pressure ratings. That if you just had one of those on the bottom of this unit or something like that, that just propels underneath the heater. The heater's open. It's an open cylinder that air is meant to move through. So if you have like a relatively like slow moving, high static pressure fan that's that far away from the heat, it's below it, would that be enough to just sort of gently nudge it in addition to just the heat naturally rising? Because we don't need high fan, right? We just need a little bit to kind of nudge it, right?
Mm-hmm. Now remind me where the monolith sits in this.
In the pipe.
Okay.
Right? You just drop it right in, and you could get ones that are 36-inch, 40-inch. You could drop multiple ones in. We'd have to figure out how much distance, heat loss and things like that go. But that's what I'm thinking, right in the pipe.
I'm looking at the heater, the specs for this heater, and it does have a CFM, or it talks about CFM, but I don't really quite understand how it works. I'm still looking.
I think it's with the CFM that it can tolerate, because it's meant to actually be in a duct. It's meant to have air flow through it, which is good. Yeah.
Okay.
And I talked to these guys today. Oh, sorry. Go ahead, Ling.
I think it will probably need a fan. But I'm not sure how it will work if the air is only blowing one way.
Yeah.
It could be tough fluidics wise.
Do you think, Ling, do you think it would be good to put, like, do we think like a relatively weak but sturdy non-meltable fan below it that is spinning would be enough to sort of push air up?
Yeah, I think a fan will be needed regardless, and you can even use the same fan, but I think my concern is more like if the air blows one way, then where does the air molecules go? I'm sure like most of you guys are know what I'm saying, because like if the pipe is very narrow and the air is blowing one way, then the air molecules have to come back somehow, or else it's at a dead end, or you can open the chamber but then you lose the heat. Plus you need mixing, right? We need to mix the air somehow. So I'm trying to think about how to do that.
So what if the damper at the top is closed and you have a bit of a chamber between the damper and the monolith, and it's just space where the air blows through from the bottom, goes through the monolith, kind of churns around, and then it has to reflect isn't the right word, but it's got to go somewhere, and so it comes back through the monolith, maybe through different holes. The whole thing would be kind of chaotic, but it would be going different directions at different holes just because of the chaoticness of it.
Yeah, I think that's originally what I was saying with the double cone HVAC thing that we had. So we would just have to make sure we get a pipe that is large enough that it can handle that kind of curving of airflow. It needs to, like, the pipe needs to be like a two-way street.
So would it be you'd have the monolith that would be in the middle, but you'd have some gap between the walls, and then you have some head space on the top, like David was explaining, right? Like an empty space, and that the heated air would go up, but it would give it some space where it could either keep moving around. Is that kind of what you mean?
It doesn't have to. It can be. It depends on the size of the holes in the monolith. Like if the holes are bigger, you can just use the monolith as a pathway. If they're really small, then I think we will have trouble with like both sides of the airflow. If the holes were really small, we would have to we'll have to maybe rethink how we do that, because then it would be hard to heat the. We don't want to, like, if the holes are really small, we don't want to have really big gaps on either side, because then the air will definitely just go through the big gaps and never go through the monolith. Then like the resistance will be too high through the monolith. We're trying to heat inside the monolith, so depending on how big the holes are, I think we have to go through the monolith.
Yeah.
Kirsch gave us a specific recommendation on the holes. It's the 100 cells per. It's pretty small. You know,
Mm,
But for what depth? Right. I think if the monolith is short, it's going to have an easier time getting through the small holes than if it's thick.
yeah, yeah. I mean, we could do is would it make sense to have they have these really relatively narrow ones. They're like a few inches tall, but they're 6 inches. It'd be interesting if you put like 6 of those in, and there's like a little space in between them, and then there's no room between it snugly fits in. There's no room on the side, so the heat has to go up, but then it has these little chambers that it's able to sort of go into. I don't know. Does that make sense? Or
Yeah, it gives it an opportunity to mix a little bit before going into the next one.
yeah,
It sort of sounds like the air resistance through the monolith has to be the same as the return path back to the fan.
yes.
So we would play with the area of the what I'll call the bypass around the monolith that is the return air to the fan. We'd have to tune that opening to have the same resistance as the air through the monolith.
can you explain that a bit more, Jay?
So you have the monolith, like Len said last week or the week before, the area times the length is going to be your airflow resistance. And then you'll have a path that goes around the monolith that takes the return air back to the fan around by the heater.
Mhm.
Okay,
So those two air resistance paths have to be the same.
I'm looking at the formula for fluidic resistance, and you can do a simple search, like just fluidic resistance, and the resistance is inversely proportional to roughly the diameter of the path to the fourth power. Wait, where's the length in this? Oh, okay. It's proportional to the length, one dimension, or to the first power, and then it's inversely proportional to the diameter to the fourth power. So, like both of them play a role, but the diameter really plays a role. Sorry, I should probably like paste the link for this somewhere.
Yeah, if there's anything you're looking at and want to share your screen, feel free to do that as well.
I'll just search it up and then post the link in the chat.
Okay, cool. Yeah. Kirsch said it's CPSI, the channels per square inch. So he recommended 100 channels per square.
Well, that's a lot.
Yeah, because we have to balance. You want that surface area to be able to get as much absorbent, into it. That's pretty coiled. But I mean,
I feel like we can afford to experiment, right? If we can get a 6-inch diameter disc with different diameter hole size, with different or whatever the metric is, channels per square inch.
Yeah.
So
that could be a topic for research.
We start with one that's fairly open, and then once we're sure of the rest of the process, we can replace it with more narrow ones and increase our surface area.
Yeah. And we're more worried about on the heat side, it penetrating, right? Because I think if we had that high fan, an open damper, and we suck a lot of air through with 2 openings, it's going to make it through those channels, I would imagine, right? And we're probably more worried about on the heated air, the resistance to that. Is that fair to say? Or do we think that big ass fan, if we pull that at a high air, the air will go through those channels, right?
Yeah, we can pull it through with a powerful enough fan, sure.
Yeah.
Yeah. So I sent a link into the chat. I'm not sure if it's effective for me to share screen, but there's a lot of formulas, but the one that you care about is probably the channel of circular cross section. It doesn't really matter if it's circular or or a square or whatever. It's basically very similar. It's just like diameter or length to the fourth power is
Mhm.
in the denominator.
Yeah.
Sorry, I think I need to get a door.
No, no worries. That's way above my pay grade. I'll leave it to you guys to do the math. But does that seem to be what I just opened it up and immediately got chills because it's not what I understand anything about. But that seems to be a relatively straightforward equation, right? So if we know the diameter,
Oh yeah.
And the parameters in it, whatever mu is,
what's that?
Sorry.
we just have to know the parameters like mu.
Yeah, but you don't really need to know it. You can just estimate like how much the radius or the length will affect the resistance. Basically, as you shrink the radius or the length of the hole, the hole's cross section area, your resistance will go up like by a lot, by a lot. That's all you need to know, really. And then when you increase the length of those channels, you'll also increase the resistance by a bit. So if the holes are really small, then we can imagine we may have trouble pushing the air through, and we definitely don't want like an empty path for the air to go through, and then expect it to still go through the monolith. That's probably not going to happen.
Yeah.
Hey, Lee, I just noticed this equation is just for one tunnel, right?
Mm-hmm.
So if you cut for example, the radius of each hole in half, then you'd be able to fit twice as many holes in a line, so 4 times as many holes in a given area, and they're all parallel to each other, so the resistances would go, I would assume, like regular electrical resistors. So really, it's more like the second power on the bottom. Just looking at it quickly,
Oh,
you have more holes.
there's an equation that says 2 channels in parallel have a resistance of. So if you go down a few lines.
Mhm. Okay, yeah, just what I would expect, just like in electricity.
Mm-hmm.
So if you have 2 channels in parallel, then the resistance would be, if they're the same, would be half of that of each of one hole.
Yeah, I think so. My fractions are, I can't do fractions in my head, but it's probably on the order of magnitude.
Yeah. I just asked Kirsch too because they have a fan that pulls air just like our original one through a monolith. So I just asked them like, what issues do you have, or what can you share about resistance concerns that you might have? I don't know. You might know.
By the way, Ling, this resource is very useful that you just sent.
Just Wikipedia, Wikibooks page.
Any books, yeah.
Yeah, I just Googled.
It's just like electronics.
Oh yeah, they're very similar.
Yeah. Cool. So anyway, it seems like we like the idea, if at least preliminarily, to consider these chimney parts. I put the catalog in the spreadsheet there that you can look at it and then look for other parts and stuff. But if we don't mind the metal part, but we're really looking for heat resistance and just the right shape and interconnectivity, they're chimneys. They're meant to be hot and air's supposed to flow through them. You know what I mean? So it seems like a good place to scavenge from. And then this was the other thing too that I was hoping the guy's quite interested in our project. But this is pretty cool. This thing, it takes up less space, and apparently it's like super efficient. And that could be 6 or 8 inch diameters. You can just pop it into it could be the bottom of the tube. You know what I mean? So hopefully by the end of today, I get a quote on pricing and other stuff like that. But that's another option to consider for.
Yeah, I like that it's shorter, but I think our struggle will still be the resistance of the monolith. I suspect that it's going to be expensive.
Yeah, I think it probably will too. So the other one's not that bad. I can't remember what it was. I think it was like I have it on the spreadsheet there. It's like 100.
Okay.
Oh, it's 224 bucks. It's not super cheap, but
Mhm.
if we save on other stuff, we might be all right.
Okay. Yeah, the monolith pore size, it's like throwing a curveball for me. I'm like hung up on how the holes are really small. I gotta think about how to.
With the air though, like for the heating perspective, again, assuming that's like if we have some pushed air for that, it's not going to be anything like during the absorption phase. Isn't it just sort of path of least resistance? Like if the monolith fits snugly into the pipe, like where else is the air going to go if it doesn't move through those cells?
You'll probably get partial blockage, and then like part of the air will go into the channels, and then it will go through, and part of it will get blocked just by the surface of the monolith, and then bounce back somewhat.
Mhm.
That's probably like what's gonna happen. So you won't get like full airflow on the other side. You won't feel the full airflow. And that's what I'm suspecting would happen. These are all just guesses. Um, do we have to use this monolith, or it's just Kirsch's suggestion?
Yeah, it was Kirsch's recommendation.
Okay. Can you get the part number for that, and then we can see if we can overall dimensions, or put it on the spreadsheet maybe. Is that on the spreadsheet?
The monolith.
Mm.
Yeah. I haven't put those in there yet.
Okay.
The one thing that they do have though, those monoliths, is there's ones that are like 50 CPSI, like that are much wider. But I think he had a lot of things to say about the monolith approach that were attractive just from a where do you put your sorbent, kind of place. So
Oh, I mean, I think we understand like the surface area. We want to maximize the surface area, but we also want it to make it like easy-ish for students to work with. So we want to find a good balance. So I'm sure we're not married to 100 C something
yeah,
something per square inch.
cells per square inch. Yeah, CPSI. Yeah.
But I just want to look at the specs because like the cells per square inch doesn't tell me how big the cells are. Just want to get a good idea of maybe like how thin the walls are and stuff like that.
Yeah.
Also, do we know the thermal conductivity of the monolith?
It's made out of alumina, ceramic, which I think is.
We suspect it's pretty low.
Yeah, probably.
With all the holes in it, yeah. But I'm just curious because that would, conductive heating could play a role.
Yeah, I suspect not a big role though, which is why we're moving now towards more, the convection, the moving airflow. Because then if that works right, it could go through all of the holes and get the heat inside it on the inner surface of the holes instead of waiting for it to migrate slowly from one edge.
Yeah. If you depend on conductive heating, you probably unnecessarily heat certain parts more.
We want high thermal conductivity for the monolith, right?
That would be useful, yeah.
Yeah.
Because it is, what is it, alumina?
Yeah. It's high. I just looked it up. It's apparently very high. It's
pretty good, right? But with all the holes in it,
yeah,
I don't know how that reduces the conductivity. Also, do we know the volume of sorbent per length, diameter length that monolith will hold?
I got to find out. I'm not sure what it is yet, but I think Kirsch did say it at one point on the call we had, but that was before I had any. I didn't understand what he was saying. He said that about 100 grams of PI per L, I guess, length of brick volume coated on the surface. Since you would need to make a PI solution. What's that?
100 grams, you said?
Yeah, 100 grams.
Per length.
Yeah, PEI/L. So I would imagine that's. I don't know what the length is.
So that's length, not volume, liter?
Yeah, I was wondering that. It just says P 100G per PEI/L, capital L, of brick volume.
Oh, per volume. Okay,
Yeah.
liter of volume.
Yeah. Oh, so he said, so I think it is liter. Yeah. And then he said, since you would need to make a PEI solution for the dipping process, maybe you can make a 30% WT/V, I guess, weight per volume solution of PEI using a couple liters of the solution. Just a guess, he said. I had our sorbent. That sorbent that we have in the list there, the PEI from Sigma, is expensive. It's not that bad. How many ml or is there for a gram? Or is that not how that works? Sorry.
For water, it's 1 gram per milliliter, but every material is different because of the density.
Okay.
Sorry, Chris. Technical.
No. Don't spare me if it makes sense to you guys. But I'm just trying to look at what it's about. $500 for a liter of that material, of that sort of material.
500 for a liter. Okay.
And that's a liquid liter or a powder liter?
Let me see, spec sheet. I think it's a powder, I'm pretty sure. The cool thing is we have, as Will already said, and we could talk about this next week, he has PEI at his lab, and he's got little monoliths at his lab. And so he wanted to start experimenting with this process, which he said he could do quite easily. So we could, and they have these machines that they're able to put into an enclosed, I don't know if it's a compression chamber or whatever, where he can actually run the basic experiment on that monolith to see, how much CO2 is absorbed and desorbed. He has that equipment in his lab. He says it's quite rare. So he could probably experiment with a little tiny one. I think he'll be very helpful given what he's focused on, but we'll have to wait till next Wednesday when he can rejoin us. So
I think the L, so he said 100 grams to coat 1 L, quote unquote L. Is that capital L? If so,
capital L, yeah.
Liter of monolith.
Yep.
So it's 1,000 cubic centimeters.
So that'd be a lot. We wouldn't even need a full L, right?
It's not that much. Because like like Coke bottles, like the 2-liter bottle. So it's half of that is a liter. So it's not that big.
Yeah.
But if it's like shorter, so then the cross section area will be larger.
Yeah. Okay. All right. Well, we got the spreadsheet going there. I think we would love folks to take a look at it. If there's other ideas they have, I'll report back as I get more responses. I'll find out about that little honeycomb heater if it turns out to be a deal and works well. But otherwise, that other heater looks pretty good. What did we use last time, David, to modify the temperature to be able to kind of regulate the temperature of the nichrome wire?
Well, I just had a circuit that switched the voltage to it on and off.
Yeah, it's
Controlled,
programmable. Like,
yeah, controlled by a transistor and programmed with the processor.
Okay. Do we think we could use the same thing for well, I mean, again, we'll have to, what's
probably
that?
probably have to. Yeah. Otherwise, like, so it's called a proportional integral derivative. It's pretty standard in the world of sensing and feedback.
Okay.
That's basically the most common. I don't know if it's the only way to do sensing, or sensing and feedback, but it's the most common.
Okay. Because I don't know what goes on with this wiring system they have here. It's a very simple like wire in, wire out type of thing. I don't know.
Yeah, you can heat up any heater to a PID, and then you can use it to control when to turn the heater on or off via, like, by having the circuit also communicating with the sensor. I'm like really hung up on the hole size. So I think that would be like my bottleneck in my head. I'm not a good person to ask about programming circuits and stuff, but I can think of solutions for mechanical problems.
Yeah.
If you can find a link for that monolith, Chris, then I'll see if there's similar stuff that are like maybe slightly easier to work with, or maybe it's fine as is if I see it. I don't know.
Yeah. Let me throw a few in there. A lot of these are like Alibaba. It's quite a commodity, so it's like
Okay.
I find that it's hard to find. You can find a great variety of them, but it's hard to find like very detailed spec sheets on some of these monoliths. But I'll put a few. There's like a 50 cell per square inch, 100, of different sizes, and I'll just put the links there and then give those a look and let me know what you think.
When I saw you Google search them or search on Alibaba, they look like the pore sizes were quite big. So I was really surprised that we're looking at really tiny ones. But I'm sure we can make something work.
Yeah, it'll be interesting to hear from Kirsch too, just like about how much of an issue that is for them, where they have, he was talking about that low. What did he call it again? A low something fraction, where there's just not a lot of space in that chamber, so there's not like a lot of air moving around, and they're putting forced air through a monolith. And that seems to work for them, but we'll need him to explain in more detail, why that is. But all right, cool. Let me ask one other question before we sign off, and this is kind of a Seth question, I guess. So just to look ahead for a second, when we think about taking the CO2 out of the chamber with a vacuum pump, right? And if we were to put that into I was looking at closed like compression chambers or plexiglass boxes or something, where you're feeding the gas just into that, and that could be like the bottom floor of the, potential. Who knows where we put it, but it seems like it could fit right below. I wonder would we want to put the second sensor for CO2 right on that? So it's like the air that's coming into that closed box. There, it's able to look at what's the CO2 concentration in that. So it's far away from heat, rather than putting it on the cylinder itself. Do we want to put it in the place where we're going to be putting the air from the cylinder?
That would be another place to put it, but that would be a phase 2 thing, I would think. First, we just want to see if we're getting any CO2.
Yeah, the only reason why I'm thinking of that now is because when you raised it a couple of weeks ago, Seth, I was like, oh shit, like, are we going to melt the sensor if we put it anywhere near this thing, particularly if it's on metal? So it does have implications for the parts that we select for the main thing, because we do need that sensor. So, but in theory, it sounds like it would be okay potentially to have the sensor wherever the gas goes into that's not hot. We could potentially put the sensor on that, potentially, right?
Yeah. So there's a couple considerations that I'd have to think through. One is if you're too close to this final chamber, to the storage chamber. Well, I guess in either place, right? In the main pipe or in the storage chamber, in the desorption phase, the pressure's changing, and the overall vacuum in each section is changing. And that's going to affect the readings of the sensor.
Okay.
So in addition to the temperature, so I think I'm going to need to think through, and David may be right, we may end up needing multiple, one in each chamber.
Okay.
If we're
Yeah.
unsure on how to get precise readings, a lot of times we just have no choice but to do calibration. It's like kind of laborious, but it basically means to control our environment and then know certain factors and then measure what the other readings might be and make a curve and use that curve to predict whether its future readings will be precise or not. That's what we would do in industry, but it may be fine to just estimate. Yeah, for academic.
It depends on, and it's easier or harder to do depending on how linear the sensor behaves with the temperature and pressure changes and the hysteresis effects as well.
So the Sensorian data for the, what is it, SDC4X series, the absolute maximum range for the sensor is 60 degrees C. So it couldn't be subjected to the temperatures of desorption directly.
Yeah. That's why I was thinking of something like this. I was just playing around with more from a ID perspective, but if we had this kind of thing, let me share that. I was thinking of something that kind of works like this. You have the chimney that could be attached, to the unit. And I found this cart, which is a similar price, but it has the benefit of perfectly right angle legs. So you could potentially have something where you either put a box in there or you actually made it into a box. You like enclose it with plexi. And then I was thinking that gives us a nice space on top where, David, there's all those various balance of system parts that could be neatly put in a cabinet. Maybe you put the vacuum on top of that. But then that pink button is where you put a sensor. And I don't know. I was looking it up. Some of these boxes that are vacuum chambers, they're pretty simple. It would be interesting if there was sort of a thing we could drill and put a gasket on that would allow the air to go directly into that box. But anyway, very much a stage 2 thing, but was sort of looking at how this would all sort of sit together efficiently. All right. Well, that's good ground covered. We're going to have our Texans with us again. Sorry, guys. I'll go back here. Next week, we might even just be in the lab for that, just so I might go over early and kind of walk around, and we might all be in person together. But we'll be here same time but different day next Wednesday. So
that'd be cool.
Yeah, no, I'm dying to go look at it. What I would love to have Will do is give us an in-person demo of his testing machinery, like how he puts, a sorbent in, is able to test the CO2 in, CO2 out. I mean, that's like extremely useful that they have that at UT. So I'll talk to him in the meantime, but maybe we can carve out 10 minutes or so and he can give us a tour of his equipment, which could be fun.
Okay.
All right, cool.
Do you mind if we talk action items for a second?
Yeah. You want me to end the stream and we can talk it there, or should I keep the stream going? No, there's only one.
Yeah, we can keep the stream going. I think.
Yeah.
And maybe we add on after we end the stream. So I would like to to-do list item for you, Chris, is to find links for me for the monoliths, and then to-do list for me is to do some spec reading on them.
Okay. I'm going to make a little tasks tab on that spreadsheet where we can track those there. So.
Yeah, I was going to post it on Discord, but I think it doesn't hurt to have it repeat in multiple places.
Yeah, I think that's right. Okay. Did you want to do some math, Ling, on the airflow stuff once you look at the different CSPI or CPSI?
I'm more of a gut feelings person. I may do some back of the envelope stuff, but yeah, we can never really like predict it exactly. Yeah, I may do some math, but I I feel like sometimes the formulas are different on different websites, so I'll look at them and see if they're consistent, and I'll use something to make my best estimate. But like the problem is that the resistance number, it may not tell you very much. You know that like if it increases 4 times what the physical effects will be, but the absolute number, like a resistance of 100, what does that mean, right? Like sometimes it's very confusing. Um, yeah, so like I don't have a good gauge for like what 100 psi feels like or anything. Yeah, I'll see if there's any like presentable information. If so, I'll write it on Discord. But if I can't get hard numbers, I'll still post or think about expressing my findings at one point or another.
Okay, that sounds good. So there's now a third tab in that spreadsheet called tasks. So I just added that to it, Ling, just so we do have it in a place. And every week we can maybe look at what were the tasks we were doing and how far did we get. I think would be good.
Okay, I can add it. I can add to it today. I'm just writing it in my own notes.
Right.
Is there anything else we need to do? Do we need to look at? Oh, sorry, Jade. Were you gonna say something?
Yeah, you brought up a good point. How are we going to measure airflow, recirculated airflow within inside the tube to know that the design is actually working? Because David, you said you had a lot of trouble with that, right?
Well,
Measuring
yeah,
temperature and airflow.
temperature wasn't the problem so much. The airflow, I just had this little sensor, and the answer changed depending on where I held it in the outlet of the fan, or on the inside, the inlet as well. So clearly, the airflow isn't constant across the radius of the pipe. So there might be a more systematic way to have done it.
Seth, does that help with what we know of the new sensor? Was that supposedly better? Right, it was turbulence too, right, David? It was like it was giving you readings all over the place.
Yeah, since air is invisible, it's hard to know what's really going on.
Yeah.
Yeah, I mean it's going to operate on the same principle. So the turbulence will still affect it. I can't tell. I'd have to look at the data sheets to see whether it would affect it more or less.
Okay. All right. Sounds good. The other to-do thing I'll do, Ling, is I'll add any kind of like little renderings that we do on Canva that we want to share with people. It would be good if it's awesome to post those on the Epiphyte channel on Discord, but it's also good to put them in a place. So I think if we had that in that spreadsheet where here's a mock-up of that and I have it in a folder and here's the link to it. You know what I mean? Like I can set that up.
Yeah. Yeah.
All right, cool. Okay, so J3ANX just joined late. He's been a helpful sounding board for us. So yeah, do look at the video for this. What I'll also give you, I'm going to put a read-only for this this bomb that we're doing. I'm just going to post it in the comments there so people can take a look at it. So J3ANX, if you want to give that a look, would be cool to get your thoughts. So before we hop on, pop it in there. I can also share with you J3NX on our Discord, but this is the document I was showing you before. All right, we can end the show. Maybe hang out a couple minutes afterward. The other business we want to handle, but that was good. Looking forward to having the UT guys back on tomorrow, and hopefully I'll be in their lab. But that was a good session. All right, ending the stream. But if you guys want to hang on for a second.